All right, so let's do another round of using function notation. The first thing I want to kind of point out to you is that I'm kind of doing three different versions here. In this first case, the function is defined as an equation. So it's kind of similar to what we've been doing, but there'll be some stranger things that'll come up. This function actually is defined as a table. So how do we answer our function questions, our function notation issues when I have a table? And in this situation, we have a graph. So again, how do I use function notation if I'm looking at a graph? So we have some unique situations, but we're still using the function notation. And again, hopefully you're kind of getting used to the idea. All we're just basically doing is taking a value of x and a value of y. Okay? So f of 0. Well, again, what we're talking about is x is 0. So we're putting 0 into the function. All right? And so going to my f function, we're going to come up here, and we're going to replace all my x's with 0. And so doing the top, we get 0 plus 3. On the bottom, we get 0 plus 1. And so it looks like we get 3 out of that. And so again, we're saying when x is 0, y is 3. We have the ordered pair, 0, 3. All right? And what we also have is the f of 0 equals 3. Okay? So lots of ways to answer that question. Here, again, f of 3, we're letting x equal to 3 and putting into f. So I'm just going to come to my function, and wherever I see an x, I'm going to replace it with 3. So that gives us 6 plus 3, 9 plus 1. We end up with 9/10. So again, we're saying x is 3, y is 9/10. We're talking about the ordered pair, 3 and 9/10. Or we're just using the function notation when f of 3, the output is 10. All right, so hopefully this is nothing new. We're just practicing the same. F of x equals to 0. Be careful, x is not 0. Right? F of x represents y. So we're given the output. What input creates that output? So I'll go to my function, and I'll replace the f of x with 0, and that gives us this equation right there. All right, as we learned, one way we can solve a proportion is to just cross multiply. 0 times this would be 0, and 1 times this would just be 2x plus 3. Okay, solving for x, we subtract 3 from both sides, dividing by 2, and we get x equals -3/2. So when x is -3/2, y is 0, or we've got the ordered pair -3/2, 0. Or functionally speaking, we now know that f of -3/2 equals 0. All right? Stranger case, now I'm asking for f of a. That seems a little weird, right? But all I'm basically saying is that x is a. It's like we're just changing variables. You say x, I say a. So if x is equal to a, we do the same thing we did when it was 0 and it was 3. I just come to my function and replace all my x's with a. And so it's just like I went from a rational expression in x to a rational expression in a. So I think that kind of demonstrates the fact that the f is the function name, and what here is what it depends on. So right now my function depends on a, and here's how it does. It basically depends on a the same way it depended on x. So kind of weird, kind of quirky, but it does get a little more interesting in some other features, but that's about as tough as we'll get. So what about the situation where my function is just a table? I don't have a function to place something in. Well, just remember what this means. So g of -4, I'm telling you that x is -4. So I'm asking you, what is the y value? So it's as simple as reading your table. So I can see from the table when x is -4, the corresponding y value with it is 7. So there's basically your answer. You just read the table. It's pretty easy. It's actually a lot faster than this stuff. G of 0, well, now I'm telling you x is 0 and asking you to find y. So we just go to the table, and there's 0, right? And it looks like the corresponding y value, the output, is 9. So G of 0 is equal to 9. G of 2, well, again, the input is 2, and I'm asking for what y is. What's the output? So I'll come to my table. Here's the 2. The output is 8. So G of 2 is equal to 8. G of 1, Well, again, x is 1. I'm asking you, well, what the heck is y when x is 1? But when we go look at our table, right, we can see that 1 is not in the domain, right? So x not equal to 1. My domain only consists, it's only defined for these 5 particular input values. Those are the only 5 that I know where they go. So since 1's not defined, that's pretty much what you can say here. This is undefined. I have no idea. We could guess, but your guess is as good as my guess. We don't really know. And in a function, I want to know exactly where it goes. It's undefined. G of x equals 8. Well, we're now reversing things. My y is equal to 8, and I'm asking what's x. So just go to the table. Here's a value where y is 8. We see that x is equal to negative 2. Here's another value where where y is 8, and so x is 2. So there's 2 values, right? Negative 2 creates an output of 8, and positive 2 creates an output of 8. So there's 2 solutions to that. G of x equals 10. Well, y is equal to 10, and we're trying to find, well, what x value. But when I go look at my range, right, 10 is not in the range. So y is not equal to 10 here. So what does that mean for this function? It again means we are undefined. If you're not in, you're not in. So if you're not in the domain, you're not in the range, I can't find out how to find you. So we're undefined. Okay? Last but not least, we have now a graph. And so, again, just like we read the table, all you have to do is read the graph. So h of negative 2, the way we read this is my input is negative 2. So what's the corresponding y value? So I'll go to my little graph. I'll find here's where x is equal to negative 2. And it looks like the data point that's given corresponds with 1. So h of negative 2 is equal to 1. H of 0, well, I'm telling you x is 0, and what's y? So I'll go to x equals to 0, look at the corresponding point, and that looks like it's at negative 1. So we're literally just reading a graph. H of 5, well, x is 5, and y is what? So when I go 1, 2, 3, 4, 5, there's 5, but when I look at the graph, nothing seems to be associated with it. There's no data point. So that just means that 5 is not in the domain, which means h of 5 is undefined. I don't know how to find it. All right, so you have to be in the domain in order to make the function work. It does. 5's not there. H of x equals 3. Again, be careful. Y is 3 now, and we're asking for the input. What value of x creates an output of 3? So now I'll go to my y-axis. Here's 3. And it looks like the corresponding x value, it looks like x is negative 1. Or functionally, you can say h of negative 1 is 3. H of x equals 0, right? So y equals 0. What's the x? So looking at y equals to 0, following there's the data point. So when y is equal to 0, it looks like x is 2. Or functionally, h of 2 is 0. What happens when h of x is equal to negative 4? Well, again, I'm giving you the output. Y is negative 4. When I look at negative 4, I can look and see that there is no corresponding data point that goes with negative 4. So negative 4 is not in the range. So this is undefined. So there's how we basically continue to use function notation, whether it's an equation, whether it is a table, or whether it is a graph. We're basically figuring out, did they give me x and asking me to find y? Did they give me y and I'm finding x? Sometimes it's as simple as reading a table. Sometimes it's as simple as reading a graph. And then sometimes it's as tough as putting things in and evaluating, or even solving equations. All right, so that should wrap up function notation. We'll look at some applications in the next video.